Today the objective is to learn how to multiply exponents. Before we start with that, let's go through what each part of what you might see when dealing with exponents and what we call them are. So if I look at this example, the ax to the n power, the a is going to be called our coefficient, the number in front of the variable. The x is our base, and the n is the exponent. So if I put some numbers with that, let's say I do 3x to the second power, so 3x squared. The 3 is my coefficient, the x is my base, and the 2 is the exponent. So when multiplying exponents, the important thing to remember that the rule says that when you multiply them, if you have the same bases, all you need to do is add the exponents. So see up here how I have x, which is the same base of both of these. That means that the exponents, whatever the numbers are, this case we just have m and n to represent numbers. All I need to do is add the exponents, m plus n, and I keep that base the same. So I want to explain why you end up adding the exponents when you're multiplying them. And we can see this by this example. So if I have x squared, and I write out what that is, x times x, and I have x to the third power, or x cubed, which is x times x times x. So see what I have written now. I have x times x times x times x times x. I have x multiplied 5 times, which is x to the 5th power. And if I look back at what I started with my exponents, I had the 2 and the 3, and if I add that, I get the same exponent as what I got in my answer. So that explains why it makes sense to add the exponents when you're multiplying them. Take a look at the example down here. I'm going to expand it out again. Y to the 3rd power, y times y times y, and then y to the 4th power, y times y times y times y. If I look back and I see how many y's do I have 1, 2, 3, 4, 5, 6, 7. I have 7 y's being multiplied times each other, which is going to give me y to the 7th power. So just a word of advice, because I do this sometimes too if I've forgotten what to do, because sometimes you get to a problem and you're like, I don't remember if I need to multiply the exponents, add them, subtract them, divide them. When in doubt, expand it out. Because if I expand it out, that's going to help me see what I'm supposed to do with the exponents. Like when I did this and I expanded it out, I could see I ended up with 7 y's. Well, that tells me that with these two exponents here, I need to go 3 plus 4, add them, to get my exponent. So it just helps me remind myself if I forget and haven't done it for a while. Here are a few examples that I'll go through with you. So this time we have a little bit more going on than we did in the other ones, because I have different bases. See how I have an x and a y and an x and a y? So I can only multiply exponents that have the same base. So if I look at the x's, I'd have x to the 5th power times x to the 2nd power. And I know that I can add the exponents when I multiply, so that would give me x to the 7th power. And then the y to the 3rd power and y to the 2nd power, they also have the same base. So that means since they're being multiplied, I'm going to add the exponents. So that would give me y to the 5th. When I look at the next one, I first have 2 coefficients that I need to work with. So I have a 3 and an 8, and we're multiplying, and when we are multiplying, we're just going to take 3 times 8. because that's the operation that we're doing. 3 times 8, I just multiply the coefficients. So I get 24. And then I look for any numbers that have the same base. So for instance, I have a u and a u. And I know that whenever a base does not have an exponent, the exponent is a 1. It's not always written there, but if there's no exponent, it's going to be a 1. So I have u to the first power times u to the fourth power. I just add the exponents and get u to the fifth. And then I have my w's. Same thing here. The w doesn't have an exponent, but really it's just not written there. There's a 1. And we have w to the 7th times w to the 1st. And I would get w to the 8th. And the final one here. Look for similar bases. So I have m and m. So since they're being multiplied, I'm going to keep that base the same and add the exponents. 2 plus 4 is 6. And then I also have a base of an n. Look at my exponents. The n would be to the first power. So n to the first power times n to the third power, add up the exponents, and I'd get n to the fourth. And then I have this leftover p. And there's no other p that it's being multiplied by. But I can't just forget about it and drop it off. So we have to keep him come along here. And the p would just be written down. And he would stay the same. Nothing would change because he's not being multiplied by anything else. So that would be my answer. Go ahead and try these 2 examples by yourself. Pause it. Once you're done, start the video back up and then see if you got them right. So hopefully you ended up with these 2 answers. And real quickly, let's go through why you should get these. The x's, see, they have the same base, so I'm going to multiply x to the 6th power times x to the 3rd. I add those exponents. 6 plus 3 gives me 9. The y's also have the same base. Y to the 2nd power times y to the 8th power. Add the exponents. I get the 10. And then the z to the 5th didn't have anything it was being multiplied by, but I can't just leave that, leave him go. I need to bring him along. He needs to stay in my answer, z to the 5th. Now this bottom one, instead of a variable, I had a number as the base. So I do the same thing, 4 to the 3rd power times 4 to the 4th power, since it has the same base. See how I kept the base the same, 4, and I just added the exponents and I got 7. But then I can actually go one step further because I can figure out what 4 to the 7th is. I could go to my calculator, and use it to figure out what 4 to the 7th power is, and it ends up being 16,384. Like usual, if you have any questions or any of these are confusing, make sure you make note of that in your notes and ask tomorrow in class.